So basically, after saying this, let's try to visualize it. So how is the input given to us? It's given first m and n. So we have m by n, no, n by m, pardon. We have n by m matrix. So we will be given this matrix, and really it's a strange matrix. So it says for any specific room, if there's a wall on the west, then that means on the west, let's say this is west, wall on the west, it's 1. Then if there's a wall on the north, then it adds 2. If there's a wall on the east, it adds 3. And if there's a wall on the south, it adds 4, and it adds 8. By the way, is this true? Let me quickly check it. So west 1, so this is 6. That means it's not west, this is west. So this is west, this is south. Okay, if there's a wall on the west, yes, okay. If there's a wall on the west, then you add 1 to the cell. If there's a wall on the north, then you add 2 to the wall. And if there's a wall to the east, then you add 4 to the cell value. And if there's a wall to the south, you add 8 to the value. Okay, we will be given this, and we will be given an n by m matrix. So let's try to show it like this. And then, okay, I will just write it quickly. 1, 2, 3, and 4. Then I have 1, 2, 3, 4, 7. So this is 4, and this will be 7. Okay, first of all, so this is our 4 by 7 castle, and then it gives me that, let's quickly write these walls as well. So here are walls as well. Let's make it color and thickness more. And then I have wall here, I have wall here. So yes, I have wall here, and then I have wall here. It goes like okay, so here are the walls. We are given a matrix, and the matrix describes us such a castle with outer walls and inner walls, and we need to detect the maximum sized room, and number of rooms, and also what would be the maximum size of a room if we cancel one of the walls. So does anybody have any idea how will we solve this problem? This is a very typical silver level problem. First DFS and find all the rooms. DFS means should I DFS from which position, and DFS to do what? Start from any room then that has not been visited. Okay, so let's say I'm just a minute. I'm starting from this room. I DFS this room, and then I fill that room. Then start from any other room, and how will I understand if a room is visited or not? Yeah, just a minute here. Let me see also. Manish also raised hand. Oops. Okay. If to find number of rooms, start from the top left corner, then float fill using BFS or DFS. That's exactly the answer that I wanted. Thank you very much. And then start from any room that's, yeah. Actually, as Manish says, start from, so for each position I need to start actually. For any position, for I starting from 0 to N, for J starting from 0 to M, for each position, if not marked, let's say IJ, then that means this, I have found a spot, a part of a room which has not been visited yet. In that case, I need to visit that room and I need to count that room and I need to calculate the size of that room. Okay, so if I find any part of a room which is not visited, which is not marked, in that case, I DFS or BFS, using DFS or BFS, I flood fill that room. So I say, go to IJ and you have next room number. Okay, so room number is 0 at the beginning. Room number is equal to 0 at the beginning. So if I find any place which is not counted yet, I need to call my recursive function, flood fill function, with the position of part of the room and with a room number. So when I start from the very beginning, at this point, this is not marked. So okay, visit, that means I need to visit this place. As it visits here, what will it do? It will flood fill. This is room number 1. So its neighbor, I can go here, 1, 1, 1, 1, 1, 1, 1. It will flood fill this room with 1s. Okay? And then when I get out from this recursive function, flood fill function, it will come back, it will come to this area, it is marked, it will come to this one, it's not marked. So it will call the flood fill function with I is equal to 0, j is equal to 2, and room number 2. Okay, so it will flood fill this area as 2, 2, 2. Okay, then it will get out from this flood fill again, come back, it will find this place as not visited, not marked, so we need to count this room, 3, 3, 3, 3. It will flood fill this room, then it will get out from flood fill of this position as well, come back, traverse here, you will find this one, so room number 4, then again get out and come here, it will find this position as not counted, 5, so it will flood fill 5s as well. Okay, so this is our main function. In the main function, our code to call flood fill for each position, which will count number of rooms. So at the end of this code, I will have number of rooms, and each position is marked with room number. Okay, so I need to write this flood fill function. What will my flood fill function look like? So my flood fill function is something like, I will say, it will be a void function. Visit, it will take an integer row number, and also it will take an integer column number, and it will take what room number I am flood filling this area. Okay, so when I get in, I will directly say, so marked row column will be equal to room number. When you are called with a row and column, then set it to your room number, and then I need to calculate my room size. So if I added a new spot to the room, then I can have a room size array. Let's say room size array. So room size array of this room should be incremented by 1 because I called the function with something new. Then I need to check for neighbors. Okay, I need to check for neighbors. If there's no wall and if it's not visited, I will visit I plus 1 or minus 1 and j plus 1 or minus 1, and with same room number. So I will just check for neighbors if there is no wall to this neighbor, and if it's not visited, in that case, my depth first search function will visit to I plus 1, j plus 1, whatever it is, my neighbor's position with same room number. Okay, basically this is my depth first search function. Okay, and then what else we need to do? We counted rooms, we counted the size of the rooms, and now it's time to find which wall to cancel in order to have the greatest room. Okay, now we need to find which wall to cancel. How will we find this? Any ideas? How can I find which wall I should cancel so that I will get... So after these functions, I think I will have two arrays. After this function, I will have this rooms, and also with visit functions, I will have a room size array, which one will be 1, 2, 3, 4, 5, 6, 9, and 2 will be 3, 3 will be 8, 4 will be size of the room 4 is 1, and size of the room 5 is 7. Okay, so after these functions with depth first search float fill functions, I will have this marked array field and room size array field with the sizes of the room. And now I need to find which wall to cancel in order to get the greatest room. Any ideas how will we find this? No idea? Yes, I have an idea. Who has an idea? Manish. Manish, let's hear you. Yes, okay. Yeah, here you are. Yes, Manish.
I'm not really sure how to do it. I think so what you can do is we can maybe find the two largest rooms, and then we can find any cells that like they have in common.
Okay, so two largest rooms are, so finding it, I find maximum one, I find maximum room is, largest room is room number 1, and I find second largest room is room number 3, and then how will I check if they are neighbor?
I guess we have to go through like the cells of like one of the rooms, and then see if any of them have like a neighbor of the other. And then if they don't, then we had to do the same process again without that combination, with a different combination.
Okay, with a different combination, but I think, okay, let's say room number 1 and room number 5. This has, so is this your answer?
Yeah. Then if it's room number one and room number five, then we can find a cell that they have in common, and then take away that wall.
But can it be, okay, so after finding room number, the largest room, and so you just sort this array 9, 8, 7, 3, and 1. So first you check, are those neighbors? If they are not neighbors, you check, are those neighbors? If they are not neighbors, you check, are those neighbors? Okay? If they are not neighbors, you check, are those neighbors? Is this what you say?
Yeah.
So for example, these are not neighbor, these are not neighbor, and these are neighbors, 9 and 3. Is this my answer?
Yeah.
Basically, you have 9, 3, 12, but you have these ones, neighbors maybe, and that's 15.
Okay.
So I think as long as you don't know how much it's bigger than the other, you give so higher priority to the largest room that if largest room is in the solution, then it should be the solution you say. But I think this may not be the case because largest room is just one away from the other. Second and third, total of second and third is much bigger than largest room plus the fourth room. this can be the case, which is actually our case. Maybe there are ones which are neighbor to the room number 4, okay, which is 3, and there are 9 ones. You will say that, oh, there are ones and 4, one largest room and fourth room are neighbors, so my answer is 12, 9 plus 3. But maybe 8, I mean room number 2 and room number 3, 8 and, so room number 3, 2, there are 8 twos, and room number 3, there are 7 threes. Maybe they are also neighbor, and total of them are 15. Okay, so that's why I think this wouldn't work. Do you have any other idea?
Or another idea could be like looking at the interior walls, I guess.
Hmm. One by one interior walls.
Yeah.
But actually, we don't have a list of walls, you know. We have just array, and you need to extract a list of walls. That would be also very costly. Does anyone else have any idea? So we have actually this array, this two-dimensional array, which gives us the map of the rooms. I think one of our friends also has an idea. Yeah. Is it okay to pass to him?
Yeah.
Okay, thank you very much for your idea. And oops. So I'm coming to you. Here you are. Yes, Klang?
Okay. So, if we look at every pair of horizontal or vertical consecutive rooms,
Mm-hmm.
and we look at the wall in between, um,
Yes.
we can first see if the room on the right and room on the left are they part of the same room?
Mm-hmm.
And if they are, then we can't remove that wall because that wall doesn't exist. But if they're part of different rooms, like for example, the one on the right is room number 2 and the one on the left
Mm-hmm.
is room number 1, then we can try removing that room and summing the size of room 1 and room 2, and
Yes,
we can hold this one.
actually, that's a good solution, and that's the right answer. So, as your friend says, I'm taking the microphone back. Okay. So, as your friend says, so what we do is just traverse all the rooms. Okay. And starting from the first position, who is its neighbors? 1, 1, 1. So, okay, it doesn't have any different number. For this one, who is its neighbors? Oh, 2 is its neighbor. So that means there is a wall between here and here. They are different rooms. So I can check what's the size of this? It's 9. What's the size of 2? It's 3. So that means I have a 12 solution in my hand. So I was here. I noticed that next place is a different room. Next position is a different room. So I just added room size of 1 and room size of 2, which is next room. Okay, so for this position, who are neighbors? 1, so this is already counted as solution. For this room, oh, there is a 3. What size of 2? It's 3. What size of 3? It is 8. So I have a solution of 11. It's not better than my best. So I just continue searching for other neighborhoods. I come here, here 1 and 2, here 2 and 3 again, here 3 and 4, nothing, 4 and 3, nothing. When I come to this position, oh, I will notice that I have 1 and next my neighbor, one of my neighbors, 5. So 1 is, size of room number 1 is 9, size of room number 5 is 7, which adds up to 16. So this gives me my best solution. Okay, basically what did we do is for I starting from 0 to n, and for j starting from 0 to m. Okay, I just checked if this one, if for each neighbors, if marked ij is different from marked I plus 1 minus 1, j plus minus 1. Okay, and while you are doing this, please don't forget to make boundaries first. Make the boundary check first. So I minus 1 should be bigger than equal to 0. I plus 1 should be less than, and etc. Okay, so if neighbor is different from this cell, and in that case you just check what's the total of, so room size of marked ij plus room size of neighbor, this cell and neighbor. Okay, this cell is ij, marked ij. If it's bigger than your best, then best is equal to this. Best is equal to this and best. Maximum of these. Okay, so basically this will solve our problem, but we are really running out of time. One last thing I need to discuss with this problem is how do I notice, how do I find that there is a wall? When I'm making the flood fill, you see here I just checked, I just wrote it, I said check for neighbors if not visited. But how do I find, how do I understand there's a neighbor and this neighboring cell is there's no wall to that direction? How will I check it? So for example, let's say I am in position 2, 3, that is okay. If here I am at this position, for example, how can I understand there is a wall to the north? You are only given the value of 13. Pardon, it's 6, not 13, it's 6. You are only given the value of 6, and from that 6 you should understand that there is a wall to the top, there is a wall to the right, and there is no wall to the left and to the bottom. How will I deduce this information from 6? Or for example, for this position you are given 13. When you are given 13, that means you will understand there is a wall to the left, to the bottom, to the up, and to the right, but there is no wall to the up. Almost 30 minutes. Find largest number that can be subtracted. You mean that can be subtracted as 8 from 8, 4, 2, or 1? That's a good idea. Would you like to explain it verbally, Bo, please? Should I give you? Sure, thank you. So, microphone is yours.
So,
Yes.
wait, you can hear me? Okay, cool.
Yeah, we can hear you.
All right. So, you know that because of the way the numbers are only 1, 2, 4, and 8. So, if you can subtract, there's no way to like make the larger number with the smaller numbers that are there. So, if you can subtract, let's say 8, then you know for sure that there's a wall to the south. And after you subtract that, you can just try subtracting 4, 2, and 1.
So as long as it's bigger than 8, I will subtract 8 and I will say, okay, there is a wall to the south.
Mm-hmm.
And
Exactly.
this is the way I will understand it. That's good. And so that you can, in your depth first search, while you are checking the neighbors, you will say, if it's bigger than, so value of, let's say, this is the value array, value of ij is, if it's bigger than 8, then you'll say value ij minus equals 8, and you will just visit south. Am I right? You are subtracting it, and you are visiting
No,
I plus
I guess
1j.
you would. I guess you would not visit that room because there's a wall, right?
Oh, yeah, okay. So if it's bigger than 8, I don't visit it. If it's bigger than 8, then I will just continue and subtract it. Yeah.
Yeah.
Okay. it's in my for loop, I will do that one. That's a good solution that can be implemented actually, but I have another idea for you. And okay, let's try to write.
Yeah.
Let me quickly write the wall numbers. Okay, I'm taking the microphone from you. Thank you very much. So let's quickly write the walls. So if there's a wall to the west, west was number what? Number 1. If there's a wall to the west, what would be the values if there's a wall to the west? If there's a wall to the west, then value can be, yes, odd numbers. Thank you very much. Yeah, it can be only the odd numbers if there's a wall to the west. So it should be either 001 or 0011 or 0101, or it can be 0111, or it can be 1001. I mean 1, 3, 5, 7, 9, 11, 13, or 15. Good. If there's a wall to the left, then that means the last bit of this here, you see, they're all 1. Okay? What if there's a wall to the north? Then in that case, the values should be, if there's a wall to the north, then 2 will be added. If 2 is added, then with 4-digit description in base 2, 2 should be 1, because 2 is added to your value. Okay, so this third bit will be always 1. So as it's always 1, the others can be 000, 001, 010, 011, 100, 101, 110, 111. Okay, so if there's a wall to the north, then the values can be 2, 3, 5, 6 and 7. Then this is 10 and 11. This is 14 and 15. Okay, if there's a wall to the north, then 2 is definitely added. 2 to the power of 1 is added to your value of your array matrix. So that means this bit is definitely 1. If there's a wall to the east, that means 4 is added. If 4 is added, then the third bit from the left is definitely 1. Okay, third bit is definitely 1. So other 3 bits can be 000 or 001 or 010 or 011, 11001, 100, 101, Okay, so the values are 4 and 5 and 6 and 7, and it is 12 and 13, 14 and 15. And lastly, if there's a wall to the south, then that means last bit is 1, first bit is 1, and remaining can be 000, 001, 010, 011, 100, 101, 110, 111. Okay, so the values are basically, oops. Okay, basically the values are 8, 9, 10, 11, 12, 13, 14, and 15. So looking at this tabloid, what can I say? Converting to binary. How would I get nth bit using modes? Good. They're really perfect questions, which I have a riddle for you to do that one as well. I will answer that, and I will ask you a riddle for till next week. Okay, so basically, what do I get from here? And you see, if the last bit is 1, I can easily get it from just n mod 2. n mod 2 gives me if the last bit is 1. Now how can I check if this bit is set? By the way, I will study bit set next week. Our subject is remaining part of Silver Review and bit sets. How will we make operations on bit sets? And so before going on to that one, this is also a good example for that. How can I check if this bit is 1? How can I check if 2 is included in a number? Yes, I have answers. Divide by 2, then odd. Perfect. Dividing by 2 means what? I'm just right shifting means. Dividing by 2 means I'm just right shifting all the bits. That means I just get rid of the last bit. If I just get rid of the last bit, then the second from the last bit becomes the last bit. Okay? Dividing by 2 means shifting right by once. Okay? So dividing by 2 means shifting right by once. If I shift right by once, then that means this bit becomes the last bit. Okay? So n divided by 2 modulo 2 gives me if this bit is 1. What about here? I need to right shift 2 times, which means I'm dividing it by 4. Okay, so if I divide n by 4, value by 4, and take the modulo 2, it will give me the value if this bit is set or not. Okay, so for this one, in the same manner, you can say n mod 8, n divided by 8, mod 2 gives you if this bit is set or not. Okay, so basically using this algorithm you can check if there's a wall, if the neighboring cell is in the same room, should I visit it or not. Okay, this is one way to understand it. Okay, so unfortunately I didn't have time